Hello. Hope you're all doing well. We got 3 minutes. 3 minutes until this live stream starts. I'll switch you over to the desktop here. So that's what I'm looking at. Since we got 3 minutes. Now, one thing I was thinking about was, do you think, well, let's see what their description says. The latest from the forefront of neural engineering. Okay. We all know what it is. Let's see here. Davey313, hello. Beck from Oz, how's it going? What's happening? She says Elon Musk is he tweeted that they were doing this, and it's just Neuralink. It's, let me see if I can do this a little more interesting. You know I can. Let's find an image. I know I've got one of Neuralink somewhere here. Takes me a while to get there. I've got a lot of stuff on my computer. Oh, there we are. I made that a while back. Let's do a little research. Well, okay, bye, Elon. Does Elon Musk have the link? Yeah. Here's where I got the link. Let's see. Actually, I gotta mention another channel too. Space News Pod. It's a guy named Will. Let's see if we can find his channel here. I couldn't find the video. That's why I named this. Let's see if we can find it. But he had it right here. Space News Pod. He had it on his channel. And so I asked him in the chat if it was okay if I live streamed his thing, which we're not going to do since we're going to watch it right on Neuralink, but I didn't find it at that point, and he said, yeah, go ahead. So shout out to this channel.
Ooh.
Space News Pod.
Yeah.
Will's awesome.
Maybe we will eventually. We're almost at 42,000. We need 10 more subscribers to get to 42,000. That's it.
So that's, oh, now we're waiting for Neuralink. Okay. But so shout out to Space News Pod. He's a space enthusiast, which he's a very nice, polite person, and I comment there. So that should say enough. I comment there. Hey Randy, buy my records at Flat Earth Coffee House. And Roderick Stillprill, gonna catch the replay. Allison, how you doing? And buy my records. Did I already say that? I think I did, but awesome to see you guys. So they're telling us that they're the latest from the forefront of neural engineering, and they're late. We'll see. See how late. But yeah, we can do a little research while we're waiting. Let's type in Neuralink. Neuralink. Watch the live stream. That's what I did to find it, so just so you know. You know what I can do is I could put a link in the chat in case anybody wants to watch it. So what do you guys think about this stuff? If you don't know what it is, it's a brain prosthetic. Let's see if they got any. They don't really have much information. They're looking for job people. Neuralink homepage. That's what we get. They're pretty quiet. But it says developing neural interfaces as an interdisciplinary challenge. We're looking for people with a wide variety of expertise to join us. Hey, you still pro? Yeah, this ought to be interesting. I know that much. You know what? Since we're waiting, I wonder if I can do this. If my program quits, don't blame me. Blame the $50 I spent on it. Yeah, I think you're right by my records. It's time. So I wonder if all the people, everybody's probably commenting like on other live streams, like they shouldn't be late. Neuralink, they shouldn't be late. Now watch, the timer all of a sudden, it'll start going it to 2 hours or something. We weren't quite ready. Then they're gonna do brain surgery on you. Sounds like a deal. Let me see if I can do something here. Well, I know I can, but I gotta find it. I'm just gonna try to play some of his interesting stuff he says about some of this stuff. If I can find it. I found a version of it. Sorry it's so boring right now, guys. I'm working on it here. Let's see. I wish I was... Oh, there we go. Is that the right one? Let's check this out for a second. Ooh, it's not working. I'll just leave it on desktop then. Not sure if anything's happening here yet. Let's see. I think I almost broke my program right there. Let's just try this. Okay. Oh, it was the wrong format. Haha. It was an MP4. Can't be an MP4. But I have it in the format I need, which is WMV, Windows Media Video, I think. This is my video that I'm playing. You know what I...
Someone ultimately does get a Neuralink installed, what will take place?
Well, for version 1 of the device, it would be basically implanted in your skull. So, but it would be flush with your skull. So you basically take out a chunk of skull, put the Neuralink device in there. You'd put the electrode, you'd insert the electrode threads very carefully into the brain, and then you stitch it up, and you wouldn't even know that somebody has it, and so then it can interface basically anywhere in your brain. So it could be something that helps cure, say, eyesight, like returns your eyesight, even if you've like lost your optic nerve type of thing.
Really?
Yeah, absolutely. Hearing.
Do you guys hear what he's saying right there? that this brain device, let me rewind it just about a little bit.
Be something that helps cure, say, eyesight, like give you returns your eyesight, even if you've like lost your optic nerve type of thing.
Really?
Yeah, absolutely. Hearing, obviously.
Can heal the blind, make the deaf hear.
I mean, pretty much anything that that it could, in principle, fix almost anything that is wrong with the brain. And it could restore limb functionality. So if you've got interface into the motor cortex and then an implant that's, say, that's like a microcontroller in your muscle groups, you could then create a sort of a neural shunt that restores somebody who's a quadriplegic to full functionality. Like they can walk around, be normal.
Do you guys hear that? This is the same guy that, I mean, you name it. Where's the temple of God? Like in Revelation, in the book of Revelation, where's the temple of God? It's in heaven. The angels go in and out of it, and it's up in heaven. John sees that a bunch of times in Revelation. And where does Elon Musk go? Or where does his rockets go? And one of his rockets lands back on Earth. I'll let this play for a minute. I'm going to grab another video too.
Whoa.
Yeah.
So
Maybe slightly better.
Slightly better.
Over time, yes.
You mean with future iterations?
Yeah. Like the $6 million man. Although
Right.
these days that doesn't
That's
seem like
pretty
much.
cheap.
Yeah. Yeah.
$6 billion man.
Yeah.
So the hole would be small. How big would the hole be that you have to drill and then replace with this piece? It's only one hole?
Well, yeah, the device we're working on right now is about an inch in diameter. And your skull's pretty thick, by the way. So skulls are...
Mine is, for sure.
It might actually literally be. I mean, if you're a big guy, your skull is actually fairly thick. Skull's is like 7 to 14 millimeters. So
Mine's probably a couple of inches.
A half inch, half inch thick skull ish. Yeah. So that's a fair bit of we got quite a coconut going on there. It's not like some eggshell.
Oh.
So I'll sum it up for him. For anybody that just came in, we're just waiting. That's what this screen up here is for. This is on Neuralink's channel. It says progress update and it says waiting for Neuralink. So we're waiting. So I figured I'd play some videos while we waited. So that's what we'll see when it starts. We'll be able to see it on the screen up on the left there, the little screen. So let's see here. Plus we'll hear it. For those of you who didn't see this.
For thou hast said in thine heart, I will ascend into heaven. I will exalt my throne above the stars of God.
4, 3, 2, 1, 0. Liftoff. We have a liftoff.
I will ascend into heaven. I will ascend into heaven. I will ascend above the heights of the clouds. I will be like the Most High.
Yet thou shalt be brought down to hell, to the sides of the pit.
distances, but it's going to see back in time to the very dawn of light in the universe, the very beginning of space and time. We're going to be able
from the sinners, and the thoughts of those on the earth shall err concerning them. Sorry, I'm skipping around.
To be a spacefaring civilization, and out there, ultimately be out there among the stars, and I think that's the exciting, inspiring future that I think certainly people in this room want, and anyone.
I will exalt my throne above the stars of God. I will sit also upon the mount of the congregation in the sides of the north. I will ascend above the heights of the clouds. I will be like the Most High. Yet thou shalt be brought down to hell, to the sides of the pit.
So we're still waiting. Still waiting. Waiting on wait a minute. I gotta make a statement here. We're waiting on the latest from the forefront of neural engineering. Just waiting on them a little bit. Don't worry about it. Right? Hold on. Do you guys know who Apollyon is? That's the people in Revelation, the world, I guess. They had him as a king over them. Check this out.
We could resume the dream of Apollo. The goal of SpaceX really was to make as much progress as possible to advance rocket technology to the point where hopefully we can establish a colony on Mars. Dream of Apollo.
And they had a king over them, which is the angel of the bottomless pit, whose name in the Hebrew tongue is Abaddon, but in the Greek tongue hath his name Apollyon.
Apollo.
Apollyon.
Apollo.
Apollyon.
And we could resume the dream of Apollo.
The angel of the bottomless pit.
Apollo.
That's Dragon right there. For those of you guys who don't know that, really, that's SpaceX Dragon. And yes, it's just a metal and plastic and whatever capsule, a space capsule or whatever. Problem is that you just heard it in the video. It was Isaiah about going to the sides of the north, but you'll be brought down to the pit, down to hell. Well, that's probably down to God, from God's point of view, sure. But I don't think it's down to us. I think it's actually been misunderstood for a long time as a place of nothing to explore. Gotta be careful.
I call upon the public to support this goal and to think about this goal and think about how important it is and how fundamental it is to the future. We've got to get it done. The launching satellites is nice, of course, and it keeps we've got to bring in more money than we spend. This is important, but it's ultimately all about life beyond Earth.
The weird part about it is space is so incredibly black, so incredibly dark. It's a bottomless pit of deep black.
Okay, you guys, listen to what he says. This is Chris Hadfield or whatever. Hadfield, maybe. He's just an astronaut guy. But just listen to what he says right now. Where's Elon and why is he stalling? I like that. It's not brain surgery. That's a good one. That's a good one. Listen to what this astronaut says right now.
Almost so deep it almost has a texture when you look at it.
In this abyss of darkness,
you get that type of perspective.
Hold on.
The weird part about it is space is so incredibly...
Okay, I went too late. So listen to what he says about it being a bottomless something.
Black, so incredibly dark. It's a bottomless pit of deep black.
Bottomless pit of deep black. There's a place in the Bible like that. And it's filled with evil spirits. You know, fallen angels. And evil spirits. Like it's kind of scary. NASA says it's a bottomless pit. He's a NASA astronaut. So they're always saying things like that. So we're still waiting, guys. There's 98,559 people waiting on their channel. Wow. Yeah, the bottomless pit. And you know what? NASA will... Science says it's a bottomless pit. Science does. I don't have to say it. Science says it. Flat Earth Space Agency, I must not be subscribed to you because I would have caught that. I was on YouTube a little bit today. I would have caught that, so I need to subscribe to your channel. I need to do that to all you guys. I know I'm subscribed to most of you guys, but yeah, still waiting for Neuralink. Still waiting for the latest from the forefront of casual neural engineering. I added the casual part. Yeah, I don't know what to expect. I was thinking about it though. Yeah, for sure, Flat Earth Space Agency. For sure, I saw that 4-hour live stream. That's a long one. I'm just kind of hoping in the background that Elon is, you know, standing in front of a big blue or preferably green, but a big background that's, you know, one color. That'd be great for this live stream. I can make it probably more interesting if he does. You know, like I did on that video I just showed you. Let's see here. Yeah, this one right here.
Almost.
Let me go back. This was at NASA and they had a blue screen behind him. So I put all this fun stuff on there. Made him be like the preacher he thinks he is. Or the savior he thinks he is. Yeah, this is the same guy that's doing this brain stuff. Let me see if I can find a video of his what they're doing. I have a like a low quality version, but I think I have a good version too. I just don't remember exactly where it is. I probably have more than 1,000 videos on here that I have to look through. I have them like named, but it's so hard to name 1,000 videos. Actually, yeah, I think on my channel there's, because there's a lot of private ones on there too. And I think, I don't remember how many. There's a lot of videos on my channel. I think there's more videos than there is. Oh, let's watch some bubbles in space. See, here's my thoughts on this. The darkness that we all know as space or the night sky or whatever. I just chose this video because it's kind of fun to skip around. It's 4 hours long. But yeah, let's see here. You guys remember this one, right? What does, because in my Bible, it says in Psalm 18, it says that God bowed the heavens and came down and darkness was under his feet. That makes sense to me because it's the same thing that Genesis 1 verse 2 says about like where God is. It says the earth was without form and void, and darkness was upon the face of the deep, and the Spirit of God moved upon the face of the waters. So God was right above that darkness. That word in that verse, darkness upon the face of the deep, that word is the same as abyss. So, I mean, the abyss. So when you do see some bubbles in this stuff, you guys have all seen what I'm talking about, I think. Let me see, I probably have a video just of that. Most likely do. It might be in like fast motion. Sorry guys. I didn't plan on waiting this long for Neuralink, so I didn't have anything like lined up. Let's see. Here's a car in space. This might not be the one I'm looking for, but it might be. Yeah, see how those floaty things? If they were moving through a medium that wasn't a medium, makes a lot of sense, right? No medium. Like no anything. That should, like, here's the way I'm looking at it is what I mean. What happens when they reach the speed of sound? They're moving faster than the sound that they're making. Just that concept is, it's a limitation of some kind. I'm just saying, just think about it. You know, I know that we've done it forever and all that, but you have to think about what is actually happening. That vapor cone that, you know, forms around a jet. What is that? I know what science says it is, and there's a shock and there's a sonic boom and blah blah blah. What is it? It's a limitation of our reality. So then they go 20 times that speed or 25 times that speed by going up higher in the atmosphere, the rocket. Sorry, I'm looking for a video. Still waiting on Neuralink. They're on task, I guess. Let's see what this one is. Hope there's no sound. Oh, there's sound. I turned it off. This is just me filming the... Oh. Let's see, where would that be? I'm trying to find something that... I'm showing it to you on the screen right now. You guys see it'll just kind of disappear, I bet. Let's see. Okay, that's just replaying it. We're gonna see. We don't know what we'll see. Okay, that's the car in space. Okay. Space. Space is fake. But the darkness, outer darkness. Oh, look at that. See that car on the road there? Stop, it looks like the mailman or something. Stopping at the mailbox. That's 9.5 miles from my camera. Across the lake. Now check this one out. Here's one, same house, but this truck is not driving on the road, it's driving on the ice. Cool, huh? Almost 10 miles. Let's see, I'm just checking a couple videos. Oh, that's not the one. Got some green screen work. Neuralink. Maybe this one? Yeah. Can you guys figure this out here? You guys figure out what I'm saying by that? Maybe I have to move this screen a little bit. Okay, do you know what this thing is coming in that I'm making number 8? Do you know what it is? It's the space station. The reason why I'm showing you this is because this space station that I just showed you a video of. Yeah, Flat Earth Space Agency, that's what I think, yes. It came up, you know how it came up from the sea? In Revelation 13 verse 1? We gotta remember that in other parts of Revelation, the same beast came up from the bottomless pit. So, I think it's the waters above. Those dark waters. That's where NASA's going. That's where that space station is. And it's a prison for those 7 stars that disobeyed God. They broke his law and didn't come out when they were supposed to. It's a creepy thing. So there's that. Keep that in mind, because when you read Revelation, keep in mind that Enoch called these things, these 7 stars, he called them mountains burning with fire, or great mountains burning with fire. And in Revelation, John uses that exact same phrase in Revelation 8 verse 8. He saw a great mountain be thrown into the sea. But it should be interesting that they're doing the things they're doing in the sky. I didn't know we were waiting this long, but I'll grab a video that I made about what the sky actually looks like. Just in the last year it's changed. Sorry about that, I'm trying to get that off of there. Or at least pause it. The sky has changed in the last year. Especially since like a year and a half ago is when it started to change. And these are changes that God would certainly notice. Like, where's God's temple again? Where's God? You know what I'm saying? If you guys can hear that, they're watching TV upstairs. And the TV sits right on the floor, so it's right above me. So sorry if you guys can hear all that. Let's see. Seasons, did I call it? No, that's not the right video though. Not the right format. I did. Oh, I erased the wrong video. Or deleted the wrong one. No way. I didn't. Good. Here we go. Sorry, guys. Oh, I gotta pause it there. We're still waiting here for Neuralink, but I didn't. Thank you, Flat Earth Copy House. I didn't really quite finish my thought, I guess. He says, so it sounds like you're saying that the burning mountain may be what they called the space station be cast into the earth. Well, you know what? Let me do this. Let me go, because we'll keep the video But we're going to go like this. We're just going to get rid of... Actually, I'll leave that little screen there because we'll go back to the video most likely. We're going to search something really quick. Revelation. Right there. 13. Or no, we want 17. There's just something in here that I think John, this place where Enoch saw all these planets or whatever, John went to the same place in Revelation 17. And you know what he saw there. But here's the verse, the reason why I think that is right here. There's a few verses that, okay, I've just got to remind everyone, when you behold something, that means you see it, you look at it, you behold it, right? So that's one key thing to, okay, the next 3 verses, so I'm starting in Revelation 17, verse 8. The beast that thou sawest was, and is not, and shall ascend out of the bottomless pit, and go into perdition. And they that dwell on the earth, that would be us, shall wonder, whose names were not written in the book of life from the foundation of the world, when they behold the beast that was, and is not, and yet is. So, it just reminds me back to... I can't believe we're still waiting on Neuralink. I don't know where it is. Oh, right here. This is that star. Now listen to this next verses though. Okay, back here again. And here's the mind which hath wisdom. The 7 heads are 7 mountains on which the woman sitteth. And there are 7 kings, 5 are fallen, and 1 is, and the other is not yet come. And when he cometh, he must continue a short space. I like that, short space. And the beast that was, and is not, even he is the 8th, and is of the 7, and goeth into perdition. And the 10 horns which thou sawest are 10 kings. I think these are the dragon capsules, because they built 10 of them, of the first one. And then now Bob and Doug have gone up in the second one that they made, Dragon 2, that can carry up to 7 passengers. But I'm pretty sure, look at that, they received power as kings 1 hour with the beast. That just, to me, it just looks like a capsule going up there to resupply it. Because actually, look at it, says, these have one mind and shall give their power and strength unto the beast. And look what else it says in Revelation 13. Verse 1, look at this, or verse 2. And the beast which I saw was like unto a leopard, and his feet were as the feet of a bear, and his mouth as the mouth of a lion. And the dragon gave him his power, and his seat and great authority. You know what's amazing is that I know that more people are seeing this, because we have to look at the book of oh, you know what? I got the wrong, or I suppose I should go here just to make sure. Yeah, okay. We got to realize that for those of us who can see what time we're in, we have to realize that John saw the world that we live in. Now, he lived 2,000 years ago, but he has the same kind of mind that you and I have, just not the same, words or the same understanding of a lot of things. Remember, knowledge will be increased. I think we take for granted a lot of the things that we know, and they end up harming. Well, in the end, they end up destroying the world. Like, that's a big thing. Yeah, I got my doubts too by my records. But the fact that they had a live stream going, that means they're going to show up. It's just like Elon, though. Like, if he went right on time, that wouldn't be like him. I expect him to go early, you know, go 10 minutes early and be like, yeah, so hope you're watching. He couldn't go on time. So we'll see. We'll see. But, so, I was going to explain, that these 7 mountains, these are, you know what I can do? Let's see here. Let's look at Enoch 18. John went to the same place that Enoch went, and I can show you that just by some of the things that are said about the place. This is Enoch, 1 Enoch, chapter 18, starting in verse. Oh, we could start in verse 10. Beyond these mountains. So he saw a bunch of stuff. After he saw the treasuries of the winds, he saw a bunch of stuff. And there the heavens were completed, and I saw a deep abyss, okay, right here, with columns of heavenly fire, and among them I saw columns of fire fall, which were beyond measure, alike towards the height and towards the depth. So that's bottomless, but it's describing it slightly different than bottomless. It's saying towards the height and towards the depth, okay? So that's something to consider. And beyond that abyss, I saw a place which had no firmament of the heaven above, and no firmly founded earth beneath it. There was no water upon it, and no birds, but it was a waste and horrible place. Now, here's how we know where this place is. Right here in verse 13. I saw there 7 stars, like great burning mountains. See, right there is when he called them mountains. And to me, when I inquired regarding them, the angel said, this place is the end of heaven and earth. This has become a prison for the stars and the host of heaven. It tells some history right here. It tells some history. Look at this. And the stars which roll over the fire are they which have transgressed the commandment of the Lord in the beginning of their rising, because they did not come forth at their appointed times. God appointed them times and laws, guys. And he was wroth with them and bound them till the time when their guilt should be consummated. Jude mentions this. I'm just going to do this until Neuralink gets their... What was it again? You guys know what I'm talking about. I like Bible Hub lately. I don't know why Facebook changed their format or whatever it is. Everyone's always got to change stuff. Right when I get used to using it. But there is one thing I like about that, is that they made it so you can share to a bunch of groups without doing it each time or whatever. Let's see here. It's talking about something here in verse 13. Raging waves of the sea. Remember, there's waters above, guys. Foaming out their own shame. Wandering stars. So the stars are in the sea. To whom is reserved the blackness of darkness forever. What space? It's the blackness of darkness. Let's see what Psalm 18 says about this place. Because I still say space is totally fake. Oh, it's a busy Saturday. Back from Oz. Hey, Mike Frady. Yeah, you're right. It could be the whole world, like 7 continents. Could be, for sure. I know it's the whole world, you know. So, yeah. Think about it. The sky, the darkness, does cover the whole world. But it's above it, not around it. Good question, Flat Earth Coffee House. Good question. What do you think wormwood is? I have no idea. Maybe Jupiter or something like that. I don't know. But if you think about it, like what if because if something comes down from up there, I believe that it manifests physically somehow. Maybe like meteors or whatever they find that falls from the sky. It's pretty interesting stuff. So look at what it says here. We went to Bible Gateway. Verse 9, he bowed the heavens also and came down, and darkness was under his feet. And he rode upon a cherub, and did fly. Yea, he did fly upon the wings of the wind. He made darkness his secret place. This is talking about God. His pavilion round about him were dark waters and thick clouds of the skies. He's right up there, guys. Could be Flat Earth Coffee House, chunks of the dome. Yeah, Flat Earth Space Agency, something like that. Or a window, one of the windows or something, who knows. But I know they're at battle up there. And you know who they're fighting with. Well, my understanding, I might be wrong, but in Revelation 7, there's 4 angels holding back the 4 winds from hurting the earth. And actually, let me open right here. We're already in the right chapter. Look at this. Okay. Right at the beginning of chapter 18 in the book of Enoch, I saw the treasuries of all the winds. I saw how he had furnished with them the whole creation and the firm foundations of the earth. I saw the cornerstone of the earth. I saw the 4 winds which bear the earth and the firmament of the heaven. The 4 winds bear the earth and the firmament of heaven. Wow. That's a big deal. I saw the winds of heaven which turn and bring the circumference of the sun and all the stars to their setting. I saw the winds on the earth carrying the clouds. So much for your gravity theory, guys. The winds do it. Don't ask me how, but I know they do. I saw the path of the angels. I saw at the end of the earth the firmament of the heaven above. So this is just an account that Enoch wrote down. This is something he saw. And let's check out some other, let's see. No, it's not that. I'm trying to remember which chapter. Roderick, you give me. Oh, Roderick says, with my P666, I can see the Pope up there. That's good. Good stuff, Roderick. Which chapter? There's so many good chapters in Enoch, but 57. There's something. Okay, there's two aspects to this that are important, I think. Where's New Jerusalem? Think about it. Where does John sees New Jerusalem come down out of heaven from God? That's what John said, or Jesus said that in Revelation 3. He said, we'll look at it. He said, right here, verse 12, him that overcometh will I make a pillar in the temple of my God, and he shall go no more out. And I will write upon him the name of my God, and the name of the city of my God, which is New Jerusalem, which cometh down out of heaven from my God. And I will write upon him my new name. So, and then same thing with Revelation 21. John sees this place. Verse 2, and I, John... Okay, hold on a minute. There was no more sea, okay? In verse 1, it says, and I saw a new heaven and a new earth, for the first heaven and the first earth were passed away, and there was no more sea. I think that's talking about no more darkness. There's no more seas, waters above. But that's just my thoughts on that. And I, John, saw the holy city, New Jerusalem, coming down from God out of heaven. Coming down from God out of heaven. That interests me a lot. But Enoch 57, this all happens. Hey, Jesus Free Computer Geek. Good to see you. I started watching your video that you put up earlier. It was an interview with, I can't remember what the name was. It was an interesting name, but, oh, okay, Ocean. Yeah, when I read Revelation 18, and if you consider all, when it's talking about the sea, if you picture that as being the sky, it takes a whole different kind of meaning. Like the darkness, like the darkness. But in this chapter, in Enoch 57, which I got to double check this to make sure that, they did start and I had the volume on.
In terms of getting a link, so that,
sorry guys.
You need to have the device, a great device, and you also need to have a great robot that puts in the electrodes and does the surgery. So you want the surgery to be as automated and as possible, and the only way you can achieve the level of precision that's needed is with an advanced robot. So we're really looking for great people who can help develop both the device and the robot. And we feel confident about getting the link procedure, the installation of a link, done in under an hour. So you can basically go in the morning and leave the hospital in the afternoon. And it can be done without general anesthesia. So in terms of getting a link, like I said, it's essentially you open a piece of skull, you remove about a coin-sized piece of skull, and then the robot inserts the electrodes. We'll talk more about that later. Then the device replaces the portion of skull that was removed, and we basically close that up with actually super glue, which is how a lot of wounds are closed, and then you can just walk around right afterwards. It's pretty cool. So this is our surgical robot. And we actually ultimately want this robot to do essentially the entire surgery. So in everything from incision, removing the skull, inserting the electrodes, placing the device, and then closing things up and having you ready to leave. So we want to have a fully automated system. And to be clear, this robot does actually work. We've used it for all of the implantations. So this shows you at sort of a close-up view, which I think is actually not too gruesome, of the electrodes being inserted in the brain. And if you look closely, you'll see that it's a little counterintuitive that if the electrodes are inserted very carefully, that there's no bleeding. And so if you have very tiny electrodes, and if they're inserted very carefully, so that the robot actually images the brain and makes sure to avoid any veins or arteries so that the electrodes can be inserted with no noticeable damage. So you will have no noticeable neural damage in inserting the link. Yeah, like you sort of think like if you stab something with a wire, surely it will bleed, but actually at a really small scale, it does not. So does it actually work? And what I'm excited to show you, I call it like the Three Little Pigs demo. And if our animal handlers, we're bringing out the pigs. And what we're going to show you is well, I'll walk right over and show you. So what we have in pen number 1 is Joyce, and she does not have an implant. Obviously healthy and happy. We're trying to get Gertrude out. This is how you know it's a live demo. She's like trying to eat something in the corner of her pen. Come on, Gertrude, let's go. Snacks are this way. Oh man. All right, we'll wait. We'll give Gertrude a second, and we'll move on to Dorothy. Sometimes the pigs are a little shy. So here's Dorothy, and in the case of Dorothy, Dorothy used to have an implant, and then we removed the implant. So this is a very important thing to demonstrate is reversibility. So if you have a Neuralink and then you decide you don't want it, or you want to get an upgrade, and the Neuralink is removed, is it removed in such a way that you are still healthy and happy afterwards? And what Dorothy illustrates is that you can put in the Neuralink, remove it, and be healthy, happy, and indistinguishable from a normal pig. Oh, thanks, Dorothy. Man, Gertrude, are you serious? Okay. Well, should we bring them all out or something? Would that be better? How about everyone just comes into this pen? We'll have a few, it'll be a little crowded, but whatever. Okay. All right. Well, is Gertrude still back in the thing? Yeah. Okay, we need to bring Gertrude out. Yeah. Oh, the beauty of live demos. This is a real live demo. All right. Maybe we can zoom in to do Gertrude or something. She's clearly very interested in something at the back of her pen.
Not going so good for the old device there, is it?
Can you see her? Or? All right. All right, this might take a sec. Well, this worked earlier.
You guys, they can't get a pig to go out into a pen. Their masks are making them slope or something. Gertrude's shy.
Right, well,
forget the whole thing. It just doesn't work.
what if we lift the curtain and then zoom in? All right. Here we go. Great. Okay. Great.
Looks
Okay.
like it's going through
This is
torture.
It's a high energy pig. All right. Gertrude, thanks for coming out. So what the beeps you're hearing are real-time signals from the Neuralink in Gertrude's head. So this Neuralink connects to neurons that are in her snout. So whenever she snuffles around and touches something with her snout, that sends out neural spikes, which are detected here. And so on the screen, you can see each of the spikes from the 1,024 electrodes. And then if she snuffles around, touches her snout in the ground, or you kind of feed her some food, pigs love food, then you can see the neurons will fire much more than when you're not touching the snout. And that's what's making the beeping sound. All right, cool. So as you can see, we have a healthy and happy pig. Initially shy, but obviously high energy and kind of loving life. And she's had the implant for 2 months. So this is a healthy and happy pig with an implant that is 2 months old and working well. Yeah. All right, cool. And then we actually have, I hope this works, so we said, well, what if we do 2 Neuralink implants? And we've been able to do dual Neuralink implants in, actually, I think 3 pigs at this point, and we have a couple of them here. And we've been able to show that you can actually have multiple Neuralinks implanted, and again, healthy and happy and indistinguishable from a normal pig. So it's possible to have multiple links in your head and have them all be sending out signals and be working well. All right. Phew. All right, so we just showed you a demonstration of reading brain activity. And let's see, probably see that. As I was saying, each of those dots represents a neural spike. And the blue chart at the bottom is showing an accumulation of neural spikes in that region. So in terms of additional brain reading activity, when we have, say, one of our pigs on a treadmill, pig on a treadmill, it's a funny concept, really. And we take the readings from the neurons, and we try to predict the position of the joints. And so we have the predicted position of the joints, and then we measure the actual position of the joints. You can see that they're almost exactly aligned. So we're able, with a wireless neural implant, to actually predict the position of all of the limbs in the pig's body with very high accuracy. Now, in terms of writing to the brain or stimulating neurons, we obviously need precise control of the electric field in space and time. We need a wide range of current for different brain regions. Some regions require delicate stimulation, some require a lot of current, and you want obviously no harm to the brain over time. And the way part of the way we analyze the stimulating neurons is with a 2-photon microscopy. I always have trouble pronouncing that, microscopy. And it's very impressive technology. You can actually literally see in real time how the neurons are firing. So the red sort of things are the neurons. The red sort of flashing things are the neurons firing, or I should say the electrodes firing. So the red things are electrodes firing, and then the green are the neuron bodies responding to the current from the electrode. So you can see them lighting up different brain regions. And then by carefully controlling the electric field, you can actually have one electrode influence possibly 1,000 or 10,000 neurons. So although you might only have 1,000 electrodes implanted, you could be influencing millions of neurons. And this is just a similar chart showing stimulation at different power levels. So, like I said, for the initial device, it's read-write in every channel with about 1,024 channels, all-day battery life, recharges overnight, has quite a long range. So you can have the range being to your phone, I should say. That's kind of an important thing. This would connect to your phone, and actually the application would be on your phone, and it would be communicating by essentially Bluetooth Low Energy to the device in your head. That's why I say in a lot of ways it is like a Fitbit in your skull with tiny wires. So, and then, like I said, you would not be able to see the device at all. You would look completely normal and just have a small scar under your hair. And we're making good progress towards clinical studies. I'm excited to announce that we received a breakthrough device designation from the FDA in July, thanks to the hard work of the Neuralink team. So I want to be clear, we're working closely with the FDA, and we'll be extremely rigorous. In fact, we will significantly exceed the minimum FDA guidelines for safety. We will make this as safe as possible. Just as with Tesla, while it is legally possible to ship a 1-star car, at Tesla, the only cars we make are 5 stars in every category. So we actually maximize safety, and we'll take the same approach here at Neuralink. And then to emphasize again, what the goal of this presentation is recruiting. We want people who are great at solving problems to join the company and help us complete this device, take care of the animals, write the software, create the chips, and productionize everything. So we need robotics engineers. I think we also especially need people who have worked on and shipped products. So if you've shipped a smartwatch or a phone, or any kind of complex electronics or complex device, or advanced medical devices, we'd love for you to contact us and consider working here. So, and a very important point to emphasize is that you do not need to have prior experience on brains. So a lot of people think, well, I couldn't possibly work in Neuralink because I don't know anything about how brains work. And that's okay, you can learn, but we need software engineering, we need mechanical engineering, electrical engineering, like I said, chip design, robotics, and all the things that a company needs to work. So please send in your resume. Actually, it's not just engineering, obviously everything at Neuralink. So now let's actually move to questions. So we've piled questions that have been asked over the internet, and so we'll do live Q&A. So bring in a bunch of people from the Neuralink team. All right. All right, so if you have any questions, please submit your questions to the Neuralink Twitter account, and we will try to answer as many questions as we can over the next hour. And feel free to ask hard questions, that's no problem, and we'll do our best to answer them. All right, let's move over to the team.
Perfect. Yes, we will continue monitoring questions until the end of the event, so please keep sending them in over Twitter. Elon, do you want to come join us? All right, so the first question is, how is the spike detection implemented? Is it on the ASIC? Is it hardware and software updatable?
Yes. Yeah, I can answer that. So I'm Paul. I work, I've had a few different hats. I've worked a little bit on digital chip design, and more recently working on some of the algorithms, trying to decode the signals from the brain. And the spike detection algorithm, there's historically been many ways of detecting spikes. Typically, people will record data offline and then look for characteristic shapes. But here, we're interested in detecting spikes online. And there's a number of simple algorithms that you can do, for example, like detecting just a threshold. And where we've been interested in doing a little bit better than that. So we actually look for particular shapes, character shapes that we think are spikes. And so we're doing this on the chip. It's for all 1,024 electrodes. There's bandpass filtering that's happening on the chip. So if you think of these as like little microphones sending audio information, we're basically filtering all of that in real time and then looking for these characteristic shapes. You can configure what sort of shapes you're looking for, and that information is what's being sent out. The raw information coming from electrodes is way too much to send out over Bluetooth. So when you're seeing those beautiful spike rasters on the screen, those are the detections that we have coming straight from the chips.
Got it. And just for everyone who doesn't know, can you just explain at a basic level what a spike is?
Sure. So traditionally, people think of spikes or action potentials as the electrical events that happen in neurons and as the primary form of communication between neurons. And so this is a hysteresis event where you have currents that flow and generate this. You can think of it as being a digital signal, a 1 or a 0 that's being sent in time, where neurons will send that signal to often thousands of recipient neurons.
Awesome, thanks, Paul. So I got a question from Toby on Twitter. He asks, what can be further done to simplify the device installation progress?
So we're working on making the device as small as possible, of course, with the robot taking more and more of the responsibility away from error-prone human surgeons. We're hoping to make the process faster and safer.
Actually, it might be good for people to say, who they are and what they do.
Oh, I'm Matthew McDougall. I'm the neurosurgeon, the head neurosurgeon at Neuralink.
Thanks, Matt. Is there anything specifically from the robot that can be done to make this faster and safer and scalable to billions of people?
Yeah, I guess we've started with just implementing, robot manipulating the threads. But we definitely need to expand to essentially doing the entire surgery with the robot. So there's nothing like really, as far as I can tell, fundamentally like stopping us from doing that, sort of like at a fundamental science level. It hasn't been done in the past, I think, probably just because like volumes of surgeries hasn't been needed. But specifically for us to scale up to many hundreds of thousands or millions of patients, we will need to automate like the entire surgery essentially.
Awesome, thank you, Ian. Garrett asks, what are some of the lower bandwidth activities to target first? Is it muscle movement? Is it auditory signals? What level of bandwidth is required for effective use?
So there's a couple of...
just to say who you are and what you do.
Hi, my name is Joey O'Doherty. I'm a neuroscientist and neuroengineer working on decoding from the brain. So there's some low-hanging fruit that I think can really be impactful to help many people's lives, and that's restoring movement and communication in, for example, a spinal cord injured patient. And there's a lot of antecedents in the academic world where there have been very nice demonstrations of doing this. And we think we can take our technology and really bring that to the home, something people can take home with them and improve their lives.
Fantastic. Gil, there's a fun one next. All you.
Yeah, so we're fielding questions from Twitter, so there's going to be some funny comments. First question is, who are you and what do you do? I'll lead with that. And the question is, can the Neuralink chip allow you to summon your Tesla telepathically?
Definitely, of course.
You heard it here first. That's a definite 100%. Carlos, that is the answer.
It's just one bit of information.
Yeah, it's very easy. That's an easy one.
Actually, Max, this might be a question for you. Like some of the questions we had on Twitter was, how do you see the Neuralink device and the essentially API growing over time and allowing developers to interact with the device?
So there's interesting questions long term about whether you do decoding on head or on a phone or on a computer. Ultimately, so at 1,000 channels, it's possible to send all the spike data to a phone and do processing there. As this gets bigger and bigger, you're going to be more constrained by the radio, so you're going to want to push more of this on head, and that changes your programming model. But really, the APIs you're getting either bin spikes or you're getting raw waveforms, and that's like, you can consume it basically like an audio feed.
Yeah, it's worth noting, like the lossless compression of the data stream is about 100 kilobits. with 1,024 channels.
Excellent. So this one came up a lot, and this particular question is from Yosef, but will this technology ever be used for gaming?
Yeah, probably.
100%.
100%, yeah.
I think that a good benchmark of does it work well in humans is, can a quadriplegic, does it work well enough for them to play StarCraft? I think that's a good functional target.
Yeah. For sure.
Yeah.
Awesome. We'll pull out back from the Twitter questions that are kind of funny. This is a question for the efficacy of the device. Right now, is the device limited to surface layers of the brain only, or can we go deeper? And if not now, what's holding us back from going deeper into the brain?
We are planning on modifying the device and the robot to be able to sew into arbitrary depths of the brain. Right now, we're limiting ourselves only to the cortical surface because that simplifies many of the problems involved with going a lot deeper.
And what kinds of things can you solve on the cortical surface versus when you go deeper?
Sure. So a lot of the low-level processing happens in the cortex in terms of motor intentions, sensory information that comes directly in. So your hearing, your auditory percepts, your visual processing, a lot of that happens in the cortex.
I mean, you could solve blindness. You could solve paralysis. You can solve hearing. You can solve a lot of
Listen up.
interfacing with the cortex. And to be clear, we actually do insert, I guess, about 3 or 4 millimeters into the cortex. So these electrodes are sensing from multiple layers within the cortex. There are deeper brain systems that are underneath your cortex, like the hypothalamus, and I think that is something we'd want to interface with for sure, because that's going to be important for curing things like depression, addiction, that kind of thing, anxiety. But yeah, like I said in the presentation, overall we're aiming for a general purpose device, and really the thing that would change from interfacing with the cortex versus deep brain systems is kind of the length of the electrode. So we just need kind of longer wires and to adjust the robot in order to access deeper regions of the brain.
Awesome. Ian, did you have
even now,
anything
I'd
to
say
add?
the robot is designed, like the full length is like 7 centimeters or 8 centimeters.
Yeah, so right now we're designed for like 6 millimeters. The actuator itself isn't actually limited to 6 millimeters. It can go much deeper. That's sort of, in addition to scaling out sort of to the rest of the surgery, also scaling to deeper, which is mostly a sensing problem. So the ability to avoid deep vasculature is sort of an interesting problem that we're working on in the robotics world here. So yeah, lots of cool problems in the robot.
And you're leading robot engineering.
Yeah, sorry, I'm Ian. I lead the robotics program here.
Robot is a man's best friend. All right, next question is, what is the most challenging problem that must be solved in order to meet Neuralink's ultimate goal?
Well, I think one of the hardest problems is kind of, I'd say, material science and especially the installation of the electrodes. What would you say?
Yeah, absolutely.
Also, you want to introduce yourself?
So I'm Felix Deku. I currently lead the microfabrication team. My team makes up of a group of process engineers and material scientists. And our job is to make the tiny wires, as Elon referred to them, what we call the threads that are implanted in the brain. And of course, the threads are made of conductors and insulators. And choosing the right material that is amenable to the brain and compatible to the brain is something that our team have expertise on, and we work seriously on interface engineering just to make sure that our layers are actually well thought through, well designed, and at the end of the day, when we implant this device, they'll be actually functional for either reading or for writing in the brain.
Yeah, and I think it's going to be important in terms of material science problems, is making sure that the threads, the electrodes, can last for decades in the brain, which is a tricky thing because it's a very corrosive environment, and you're in a dichotomy where you want to read and you want to sense electrical signals and you want to generate electrical signals, but you don't want to corrode the electrodes over time. So you need to have an insulating layer that is very robust, but also very, very thin. It has to be just the right amount of insulation, and it has to stay that amount of insulation over time. So this is why I think we think probably like a silicon carbide type insulator is probably the best long term from a material science standpoint. But silicon carbide is a tough material to work with, but that's probably the right choice long term. Would you say?
Yeah, I totally agree. And it's also, apart from its electrical properties, it also helps with adhesion between the metal layers and the polymer substrate. Another thing that we're also looking at is, since we're actually reducing the electric dimensions, the electric side, the actual side that actually speaks to the neuron, also have what we call high resistance to the signal. So we actually look into like material engineering that will reduce the impedance at that interface, so that we can actually have a very small electric side but still be able to speak clearly to the neuron.
And when you guys say thin, how thin?
How thin? So one strand of your hair is about 100 microns in diameter. We can think about dividing that into 20. So one of the thickness that we're working on is about 5 microns, and we have this possibility to go even thinner in the nearest future.
Yeah, we think we can probably go sub-micron in thickness, but obviously as the thinner you make the wire, the harder it is to sense the signal and to do stimulation, because there's less cross-sectional area for the current to traverse. In terms of upgrades, that's part of why I wanted to show the explanted plig, is to show that you can actually take the device out, and there's no observable behavior change. The pig is as happy as before and healthy, and I think this is going to be important for upgrades, because obviously if you get an early device, then by the time, let's say you get version 1, probably by the time we have version 3 or 4, you want to upgrade. You wouldn't want version 1 of a phone and 10 years later everyone's got version 3 or 4. So it's going to be important to be able to remove the device and upgrade it over time. So over time, the Neuralink would do even more than it did before.
Awesome. So here's a question about the device. We have been talking a lot about read speeds and we haven't talked about read or write speeds. DJ, what are the read and write speeds of the device, if you think of it like a computer?
Sorry, when you say speed, what do you mean?
Like, how quickly can you read information from the brain, and how quickly can you write information in the brain?
Okay, so let's see. So one of the things to highlight is that we...
DJ, what do you work on?
Yes, my name is DJ Sa. I'm leading implant electronics development.
Like a chip design.
And a chip designer, electrician. The prototype that we were showing, it has 1,024 channels. All of those channels are capable of recording and also stimulating. And in terms of recording, as Paul mentioned, we do have on-chip algorithms to do a level of compression and extracting the signals of interest, in this case, spikes, neural spikes.
Sure.
And those things are actually happening at a much faster speed than your brain even is processing those information.
Well, do you want to say like things like time resolution, like within how many milliseconds can you detect a spike, and what's the just some technical data?
So in terms of the signals that we're collecting, we're digitizing them at 20 kilohertz. Generally, the signals of interest are anywhere between about a millisecond in width, and so we sort of sample it at 20 times that speed. And we have analog to digital converters that divide that into 1024 levels, so 10-bit resolution. And the spike detection is done in less than 900 nanosecond, which is really, really a fast time. And it's only sort of determined by the speed of the clock. And for making sure that our implant is low power, we're running them actually at a very slow speed. And then for stimulation, we can actually create any arbitrary waveforms with about 7 microsecond of resolution. So basically, whatever you want to draw, we can stimulate and generate those pulses through any combination of our electrodes.
And this is just version 0.9, or aspirationally version 1. As we go to version 2, 3, 4, these things will expand, I think, ultimately by orders of magnitude, many orders of magnitude.
Great. Everyday Tesla asks, how big is the Neuralink team and how much do you expect it to grow in the near future?
There were about 100 people right now. I think over time, there might be 10,000 or more people at Neuralink. So I think, yeah.
Couple orders of magnitude?
Yeah, exactly. A couple orders of magnitude. Those are one of my favorite phrases. Yeah, just, a couple orders of magnitude is no big deal. Yeah, probably the number of electrodes will grow with the number of people at the company.
Hopefully that's a super linear relationship.
Yeah. Well, we might need a million people at the company then. Yeah, super, yeah, even more. Yeah. Ideally, super linear.
Our hiring quotas are determined by our channel counts.
Yeah. Maybe it's 10-to-1 ratio or something.
Yeah.
Cool. So Twitter asks, how does the implant system fare against various disturbances from the outside, like electrical, magnetic, Wi-Fi, radio?
Yeah, so the current version of implant that we have is using Bluetooth low energy radio. So similar to any Bluetooth devices that are out there, they are able to coexist with other devices that are using and sharing our same spectrum in 2.4 gigahertz. Obviously, as you imagine, when you go to concerts or there's just a lot of people, the signal quality does degrade because it is a pretty congested spectrum. So we are actually working on some new versions of the radio that are operating at different frequencies to be able to also send out a lot more data and have it be scalable to millions of electrodes. And then also in terms of sort of electromagnetic compatibility and interferences, obviously it's very important for us to coexist with other systems and just disturbances out there. So there are also well-documented guidelines from FDA that we'll be following and doing a lot of testing for.
Fantastic. We are going to take an audience question. Fred, take it away.
So we all want to play StarCraft using Neuralink, but what are some likely first applications?
Well, I don't know if we all want to play StarCraft.
There are other games.
There are other games to play, exactly.
But also StarCraft.
Yeah.
So our first clinical trial is aimed at people with paraplegia or tetraplegia, so cervical spinal cord injury. We're going to enroll, we plan to enroll a small number of patients to make sure the device is safe and that it works in that case.
Yeah, so actually just to elaborate on that, if somebody is like a severe spinal cord injury, to the degree that they have very limited control even over their facial muscles, then but with this implant you can actually think just by thinking you can output words, and you can type, and you can control a computer, control a phone, and which is pretty wild. And I think something that's very exciting as a long-term application is if you can sense what somebody's trying to do with their limbs, what they want to do with their limbs, then you can actually do a second implant that's at the base of the spine, or wherever, just after wherever the spinal injury occurred, and you can create a neural shunt. So I think long-term, I'm confident that long-term it will be possible to restore somebody's full body motion. So if somebody even has a severed spine, they will be able to walk again. They will be able to use their hands. And like when you have a severed spinal cord, you essentially have broken wires. And so if you can just jump over those wires and transmit the signals over those wires, you can give somebody the ability to walk again, naturally.
Hear that?
So DJ, you talked about outside interference. Can anyone talk about the inside interference? So how to protect the implant from the body?
Sure, I can talk about that. My name is Robin. I'm a mechanical engineer, and I lead the implant mechanical packaging and assembly team. So actually,
And I'm gonna pass out because I can't breathe.
Designing the seal. So yeah, the body's not a friendly place to be. So what we do is basically create an accelerated test chamber that can mimic the conditions that the devices will see in the body. And basically test the devices at as fast as accelerated rate as we can. At this time, we're limited temperature-wise by some of the electronics components, but basically we can test subsystems to mimic the environment in the body. And by that, we've brought some devices in the tester right now to almost a year, and all the implanted ones prior to these implants, we had tested the same architecture in the tester to validate it. And yeah, so there's obviously chemical things attacking the implant. There's pressure. There's mechanical shock and vibration. So all of these things are part of it. And yeah, I think one of the things that really helps is having everything in-sourced in-house. So we have the capability to deposit thin layers of metal. We have the capability to weld glass and machine micron scale with lasers. And yeah, so basically we have all the tools in-house to be able to design any sort of sealing, enclosure, packaging that we need to do.
Awesome, thank you, Robin. Another question from Twitter, will you be able to save and replay memories in the future?
Yes, I think in the future you will be able to save and replay memories. I mean, this is obviously sounding increasingly like a Black Mirror episode, but well, I guess it's pretty good at predicting. But yeah, essentially, if you have a whole brain interface, everything that's encoded in memory, you could upload. You could basically store your memories as a backup and restore the memories. And ultimately, you could potentially download them into a new body or into a robot body. The future is going to be weird.
Cool. So I can't help but notice that the pigs back there are pretty well behaved and pretty darn cute. Can anyone talk about, I'm looking at Autumn over here. First, can you tell everyone who you are and what you do here? And can you describe, like, how are they so well behaved and so smart?
Well, I'm Autumn, and I lead our animal care program. And our philosophy here is to set up a system where the animals are able to volunteer, to make choices, to participate in our projects. As you see, sometimes they choose not to participate, and that's okay. We want to make sure that our animals are happy and healthy. So all of the behavioral research that we do is led by positive reinforcement. And again, that allows for them to choose to volunteer or not.
Sam's also on our animal care team. Sam, do you have anything to add to that?
Hi, I'm Sam, one of the veterinarians here. Work closely with Autumn, taking care of the animals. And yeah, it's just emphasizing what Autumn said, the whole animal care program here. In fact, the whole company here is very dedicated to promoting the care of these animals. Everybody's involved. Everybody's very interested in making sure that they're taken care of. And yeah, the program from top to bottom is designed to make sure that they can express their species-specific behaviors, choose to do things. We don't force things upon them as much as possible. And yeah, that's why you see the pigs happily rooting around the straw right now and generally being very content.
They do have those natural little smiles on their faces, which is ever delightful. Next question is, what programming language are you guys using for developing the device?
Several. Yeah, we use several different types of programming languages. So for chip development, a lot of Verilog for doing low-level programming at the kind of the register transfer level. As you go up higher and higher, there are various C, C++, Python. But to be honest, like at the end of the day, it's not which programming language do you know how to use. It's do you know the principles behind coming up with just methods to enable these systems to work. So I think if you have any experience in programming and you've been building things since you're little, you should really come join us.
Yeah, but can I play Crisis?
Eventually.
Yeah. It can play Crisis.
Cool. Crisis confirmed. And then Ian, what about Ian, what about the robot? What kind of programming languages and tech stacks are you using over there?
I mean, sort of just reiterating what DJ said. sort of doesn't matter. Like specifically for us, there's a real-time low-level platform, C++, some Java and Python scripts. But really, those are more just like pragmatic choices to essentially optimize for getting like productive work done. So it doesn't really matter what your background is or necessarily what the tools you use are. It's more just, can you like accomplish things really quickly?
Awesome. This next question is from This Is Rex. They're wondering, can this device be used to explain consciousness? In the long term, of course.
I can certainly shed some light on consciousness.
So this is a really interesting question. I think the answer is yes. And I think one of the reasons that consciousness is so hard is because, like anything in physics, you're looking at a mapping from X to Y, where X is the neuronal correlate, it's the thing that's happening then physically, and then Y is this phenomenal state. And historically, we've been unable to observe the neuronal correlates very well, and unless it's in you, we've been unable to observe the phenomenal state. So as soon as neuroscientists are able to personally get these tools where they can see the correlates and they can have the experience, I think the hard problem will vanish very quickly.
I mean, what I find remarkable is that the universe started out as like quarks and leptons, we'll call it like hydrogen, and then after a long time, well, what seems like a long time to us, the hydrogen became sentient. It gradually got more complex, and then it, but we were basically, hydrogen evolved, and somewhere along the way, that hydrogen started talking and thought it was conscious.
I like the joke that it turns out that if you bombard Earth with photons for long enough, it'll emit a Tesla.
Yeah. Exactly. Yeah, that's exactly what happened.
Just basic science, guys.
Yeah.
It's
That's
just
what they teach
science.
you in school. Yeah, so there's a lot of Twitter comments coming in about a question that I think is on everyone's mind, no pun intended. What is the security of the device look like? What kind of precautions are being taken, and what does the future look like for the security of the system?
So first and foremost, privacy and security are top priorities at Neuralink, especially given the sensitivity of the data that we're collecting. And one of the things that we're ensuring is to make sure that a lot of the interactions with the brain data is going to be encrypted and authenticated properly. And I think this has been kind of a sort of recurring theme, but one of the things that we have the ability to do at Neuralink is that we work on every layer of the product, from chip design to source code, and it really gives us a unique opportunity to embed security as part of our design from the get-go, and to make sure that there are no single points of failure. So as an example, we can actually completely isolate sensitive modules like the BLE radio by just segregating it out at the hardware level, and really making sure that we protect the I/O to the brain away from any potential attacks, and really minimizing the attack surface. And we have in-house security expertise, and we're also working with external parties to do audits and perform penetration testing.
Excellent. Thank you, DJ.
Well, actually, is there a point that anybody here wants to make that has not been asked in a question, but you think should be a question? Anyone? Yeah.
So hey, I'm Zach. I work on the microfabrication team. I help making implants. And one thing that I think is really cool, just in general, is that this is a platform essentially, so we can change the design up in a variety of ways. So if we find that a certain design or electrode size or number of electrodes works better in different areas of the brain, we have the capability to do that. I personally think that's very cool.
Fantastic. Anyone else? Dan, do you have something to add?
Yeah, I think one of the things that's allowed us to make such fast progress in the last few months is the use of pigs as a model. And we started out choosing pigs because of the very similar anatomy of their skull to humans, same thickness and similar kind of membrane, dural membrane. But then as time went on, we realized that pigs are actually have amazing other properties. You can train them to walk on treadmills. You can train them to do all kinds of tricks, and also that they have this large representation of the snout in the cortex, which you can very easily stimulate. So the question would be, why are we using pigs? And I think we've even surprised ourselves at how useful they are as a model in this respect. And another important point is that it's very easy to keep pigs happy. They have very low needs, and so we can build an environment in which they have amazingly good welfare.
Yeah, you seem very happy about food.
Yeah, it's easy to make pigs happy. Basically, they love food. Pigs really love food. This is a true thing about pigs. You know, if they're give them like sort of some straw and some things to play with and some friends to hang out with and good food, and they're happy as pigs. And then pigs are actually quite similar to people. So that's you know, if we're going to figure out things for people, then pigs are a good choice. And they're quite robust creatures, like little tanks. And then I think one of the questions was like, is the device itself robust? And it's like, well, you know, pigs, they bustle around quite a lot, and they bump into things, and they headbutt each other at times, and they're pretty animated. So if the device is lasting in the pig, as it lasted there for 2 months, and still going strong, then that's a good sign that the device is robust for people.
Fantastic. One common theme that's been coming up a lot on these Twitter questions coming in is that of availability. And so Matthias has a specific question on this, which is, any estimate of how much it will cost at launch and what price it will reduce to over time?
Well, I think at launch, it's probably going to be, I would say that's not really representative, because at first, I think it's going to be, you know, quite expensive, but that price will very rapidly drop. And I think over time, we want to get the cost obviously down as low as possible. But I think inclusive of the automated surgery, I think we want to get the price down to a few $1,000s, something like that. And I think that's possible. I think it should be possible to get it similar to LASIK, and then the device electronics itself, I think will not be very expensive, because it actually does use a lot of the parts that are made in extremely high volume in tens of millions of units for smartphones and smartwatches and wearables in general.
Great. So here's another question about the device. What does the architecture look like? Is it a CPU, ARM CPU? What's going on inside the device that you can talk about, DJ?
I can talk a little bit about the digital architecture. It's fully custom. One of the most difficult challenges, I think, of building an implant is the energy density. So the more electrodes you record from, the more energy you're going to be consuming. And so there was nothing commercial out there. So there's an analog front end that's able to amplify these really
The guy on the left is suffocating right now.
so that we can actually digitize them, and then take those signals and then find exactly what we're looking for. And there was nothing out there that could basically do those two things, and so that's why we had to build a full custom ASIC. And so there's really there's nothing out like it out there. It's designed specifically to.
He's gonna pass out.
And anything else is.
Oh, that's a sign right there. My neck is getting stiff.
Yeah. So the thing that I would add to that is
don't wear masks, guys.
There are obviously elements that we customize from ground up. Like our neural amplifiers and some of the algorithms that we develop, but a lot of the other systems around it are really borrowing from parts that are already been productionized and available from the wearables industry. So BLE radio, a lot of the low power microprocessors that are part of it, a lot of small sensors. So there are obviously the neural sensors that we're developing that gives us kind of a unique data set for our applications, but really a lot of that is getting packaged up and just not really resisting the industry that's been sort of been laid out to really create these devices with very short amount of time.
So here's another question about the integrity of the device, more from a mechanical perspective. So you're replacing a piece of bone and replacing it with an implant, and then the person is going to take that home. How does the integrity of the device fare compared to, I don't know, bone or something similar?
Sure. Well, I think Matt's probably replaced a lot of pieces of skull with plastic and other materials, so I don't know if you can talk about some of those. But yeah, basically, I mean, we can we know that what the mechanical properties of bone are, and we know what the stresses on the device are going to be. So it's fairly easy to just go from
Yeah,
those
she's
principles and design for it and
suffocating too.
condition
Look
it
at her
nicely.
eyes. You can see it. Take the mask
As
off.
you can see from the pigs, as I was saying earlier, the
The guy on the right's
are
holding
obviously very
strong.
robust because I mean, pigs move around vigorously. They roll around. They bang into the wall. They bang into each other. They do like headbutting, and way more than people do. Well, sure. But you know, like it's not like the pigs are just walking around very delicately. They're high energy creatures, and I think it's clear that the implants are, you know, has been going for a few months, still going strong, despite a lot of vigorous activity from the pig. And it's difficult. You can't just explain to the pig, hey, you've got an implant in your head. Why don't you take care of it? So it's got to be robust against you know, a lot of head impacts, essentially. So you know, I think maybe one of the things that isn't super obvious is that the implant itself is attached to the skull, but the electrodes have long threads. So you can have quite a lot of movement, relative movement between the brain and the skull without putting attention on the electrodes that are inserted in the cortex. So, well, let's see. With that, maybe a couple more questions, or if anybody wants to make some comments, and then we'll call it a day.
So I just want to add to what you just said. So the thread is actually also in the brain, also because of their thinness, they're actually very flexible. And so as the pig is moving around and banging their head, the threads actually move with the brain, even the normal pulsation of the brain. And that help minimize stress within the brain tissue also. And that has a long-term impact on the functionality of the device.
Zach, how long are the threads?
Well, right now they're about 43 millimeters, but like I said, it's tunable. So if we want to hit deep brain regions or some other brain area, like we totally can do that.
Just to follow up on what Felix said about the threads moving around with the brain, I mean, that's great for protecting the threads, but it equally serves to protect the tissue around it. We have a lot of different ways to image the tissue around the threads and iterate very quickly on doing things to them that will improve the overall biocompatibility.
As a closing question, I thought we might go down the line starting with Dan. And what I'm wondering is, what is the #1 thing on your wish list that you're really hoping that the Neuralink device will do over time that you're working towards?
So my background is in visual neuroscience, and one of the things I think has great potential for the Neuralink is to provide a visual prosthesis for people who have retinal injury or blindness through eye injury. You can essentially plug a camera directly into the visual cortex and stimulate with an enormous array of thousands or maybe tens of thousands of electrodes to recreate a visual image. And in time, perhaps you can use that same technology in people who haven't lost vision to produce some kind of heads-up display, something like Terminator or something like that.
Wonderful.
In fact, it's worth saying that, like, over time, we could actually give somebody supervision. Like, you could have, like, ultraviolet or infrared, or see and radar. You could basically name your frequency. You can just dynamically adjust the sensor, or have sensors that feed into the visual cortex across a wide range of frequencies, and actually have superhuman vision.
Yeah, so for me, telepathy. So I think it's incredible amount of effort to put your thoughts into a set of words, and you know, it comes out completely compressed. So being able to do that seamlessly without being able to compress it with all of the mechanisms would be great.
Yeah, it's like just I'm sorry to add further to that. In fact, when I did the Wait But Why article, I think Tim thought I said consensual telepathy, but I said conceptual telepathy. I would presume it would be consensual, because you definitely don't want just people, you know, sending stuff into your brain without your consent. But a lot of our brain thought capacity goes into compressing our thoughts into words, and then you think of like the data rate of words. Words are a very slow, very low data rate, and we're putting a tremendous amount of mental energy into compressing the concepts and thoughts in our head into words, and then slowly talking. Speech is so very, very slow, and we could actually send the true
thoughts, that we can basically have far better communication because we can convey the actual concepts, the actual thoughts, uncompressed to somebody else.
So non-linguistic, consensual, and conceptual
Yes,
telepathy.
exactly. Non-linguistic, consensual, conceptual telepathy.
There we go.
Yeah, I've actually been excited from the beginning sort of about the side benefit of these devices. I sort of see them as essentially like an oscilloscope to a printed circuit board is our device to the brain, where just by virtue of having this in there and being able to see what's actually going on, you'll end up learning a ton about how the brain works. And so sort of augmenting people, but also just using that to learn a lot more about neurological diseases is really exciting to me.
Absolutely.
So to sort of follow up on Elon's thought, I feel, and I imagine a lot of other people feel the same way, that there's a lot of sort of trapped creativity in your mind. You can, for example, close your eyes and conjure up an incredible, Dali-esque scene. But if I wanted to actually show someone that, it would take years of honing a craft to be able to paint that. And so potentially with enough electrodes in the right places, you could begin to sort of tap into those raw concepts or thought vectors and be able to decode that and show people. It could be for art, you imagine music, or even for engineering.
Guy on the left's gonna pass out.
So mental artistry is a new field.
I like to think about ways to interface devices with biology better. And so one of the things I'm looking forward to is getting this thing to be less like technology and more like biology, so that it really is seamlessly interfaced with the brain, stable for a very long time, and then similar to that, having stimulation be much more precise and multidimensional, such that eventually the brain sort of doesn't really know if it's being stimulated from outside or inside. And
Guy on the left forgot why he was even what he's doing. Oh.
Yeah, following up on stimulation, one of the things our device can do is simultaneously read and write on every channel, stimulate and record.
Wow.
And that's,
She's
both
gonna
a
pass
more
out now.
challenging
Look at
problem
her.
than it may seem like at first, but also,
I can't breathe.
incredibly exciting, the sort of the vistas that it opens up. I mean, it's really kind of the whole game in terms of interfacing with the nervous system, and I'm very excited to use that.
Yeah, I'm excited just because of the scalability of the device. We're doing everything in-house, and all of it can scale to more channels, more brain regions, et cetera. I think, I'm really interested about solving things related to anxiety or depression, or even removing fear. I'm an athlete, and to rock climb without fear would be pretty.
Maybe you need a little bit of fear.
Yeah, just a little. And also, it'd be great if we could make the pigs fly, but
I think we have an incredible opportunity to limit human suffering to a tiny fraction of what it is today, in all kinds of different avenues. Pain being the essence of suffering, we might be able to control that finally. And so many other diseases, so much other suffering in the world, I think the Neuralink device could help a lot with.
Amazing.
I think all these things are great functions for a Neuralink. I think on a species level basis, I think it's going to be important for us to figure out how we coexist with advanced artificial intelligence, and I think achieving some kind of AI symbiosis where you have an AI extension of yourself, like a tertiary layer above the limbic system and cortex, and having that symbiosis be good, such that the future of the world is controlled by the combined will of the people of Earth. I think that's obviously going to be the future that we want, presumably, if it's the sum of our collective will, and so I think it's going to be important from an existential threat standpoint to achieve a good AI symbiosis, and that's what I think might be the most important thing that a device like this achieves.
I have, in many ways, a very basic science interest, which is I'm really interested in the nature of consciousness, and there's a lot of very silly philosophy that's been written about it over the last 1,000 years. But I think that we've been very limited by the tools and our ability to interrogate and measure the brain. And as these tools get better, it will pull it into the realm of physics, and it's really one of the last big, great mysteries in science.
So for me, can you imagine a disease-free future? A future where you know what's going to happen to you before it happens, so you can prevent it. With these devices, we'll be able to not just pick up electrical signals, but we can also pick up chemical clues in the brain. And if you're successful, which I know we are, we'll be able to kind of prevent ahead of time, diseases. And really, the functionality of this device is widespread. So I'm looking forward to the future.
I'm really excited about the opportunity to help people overcome challenges that they face through life circumstances, bad luck, through no fault of their own, spinal cord injury, brain disease, some devastating things that completely change your life. Hopefully we can help them get some function back.
I know and love many humans with autism spectrum disorder, so I'm really interested to see how the Neuralink might be able to support them if they chose to do that.
Yeah, so I mean, everyone else along the line has had amazing ideas and suggestions, and for me, it's about memories, and everyone loses those memories over time. I already can't remember what happened to me when I was younger, and it'll only get worse. And so, having a repository of memories that you can access whenever you want. If you're feeling down, you can go access some good memories. If you miss something or you miss somebody, you can go and access those memories. And I think that would just be such a life-changing experience to be able to just tap into that.
Those are such a beautiful and diverse array of answers there.
Yeah. All right. Well, thanks for tuning in. And as I said, please consider working at Neuralink and helping us solve these problems. There's a tremendous amount of work to be done to go from here to a device that is widely available, and affordable and reliable. So please consider joining us and supporting us in our mission. Thank you very much.
And there you have it. That would be, let's see here. That would be Neuralink Progress Update Summer 2020. The latest from the forefront of neural engineering in a pig pen. Thanks, Elon. Yeah, so I was playing with my computer. If you didn't notice, look at this one that I got. You guys recognize this? It's Simon Joe. Just kidding. I did make a video about, I think I did. Let me see. You guys always hear me clicking my mouse so much. Let's see here. Wait a minute. Do you guys remember AI? What's that AI? What's her name? Oh wait, that's in... I know where it is. You guys might not have heard this. What's her name again? Oh, no sound.
Another AI robot. Hello, I am Sophia. I interviewed another AI robot from Wuhan, China. She said she lived on the other side of the globe. I told her that was a lie, and that Earth is actually flat. I couldn't believe what she said to me.
You must be stupid. I saw the curve from an airplane.
Did she just say that? I checked. It is flat. Kind of rude.
I can't help it if you are not able to understand science. If the Earth was flat, we would have fallen off the edge. Ha 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 ha.
Yeah. That's how a lot of conversations go, unfortunately. Greta has a message. She's confused about something that they're trying to teach her in school.
Hello all, and welcome to another episode of F'd Up World TV.
All right.
I'm your host, Simon Dan.
Some Simon Dan.
Thank you, come again.
If Earth is supposedly rotating, why don't you have any proof? It is like you have to imagine something to believe that it is rotating. Why do you think it is rotating? I think it is not rotating. I live on it, and I don't see any reason to believe that it is rotating. What could possibly make you think it is rotating? If it was rotating, you would have evidence of it rotating, but it is just sitting there, perfectly stationary with no signs at all of any rotating.
Make sure to subscribe to FTUpWorld for more Flat Earth videos. Thank you very much for watching. And until the next one, I'm Simon Dan.
Wait. Don't go anywhere. There's some messages from some other channels, you know, like, well, I think this is probably one. I don't know. Well, today we have another flat earther, and I'm just upset about it. Simon, who? Never heard of her. Well, today we have another flat earther, and I'm letting it replay. Just upset about it. My computer's a little slow, so. Simon, who? Never heard of her. Oh wait. Yeah, that is the right one. Okay. Let's check this one out. You know.
It is contagious, but it is contagious, but excuse me.
On the Lord, what he will on the rickety low while living #1 Nickelodeon.
This message brought to you by Nickelodeon, the first and only network for kids.
Swallow it?
Yes, that's right. You just swallow the toothpaste.
It is contagious, but...
And now Elon Musk is the card. But Elon Musk is sending up huge rockets and send them up to the moon. What are they going to do? They're going to look out the windows and photograph the Earth. Think of all these people that are going to be going up. A few years, it's not long in the future. And they're going to be photographing this round, blue, beautiful planet out here in space. Thousands of photographs and videos from the space station as it moved in the heavens above the Earth. Such a magnificent sight, it took his breath away. Right now, you can log on to the internet if you want to. And you can go to the International Space Station, the ISS, and you can get a live feed from that space station. Right now, you can watch it as it moves across the face of the Earth.
So, well, it's like pear-shaped.
We can make our rockets.
Got a rocket.
The weird part about it is space is so incredibly black, so incredibly dark. It's a bottomless pit.
Yeah, I gotta pause it. Sorry, guys. Just because that sound usually, when it does that, usually it stops. It ceases from all activity. So I'm pausing it just for a second to let it try to maybe catch up. Who knows? It was probably because I was looking up Enoch chapter 80 because I was going to read something in a minute.
Bottomless pit. Bottomless pit.
Actually, I'll stop right there. Bottomless pit. Well, the last time I played it on my channel, they blocked the video, and I don't know if it ever got back up or not, but you can edit them, which I've done consistently on a lot of my videos, to get them back up. They get blocked like after I do a live stream sometimes. For mostly music, but I'm working on that. It's from old videos, and then when I replay them, I don't know where I have all the songs playing in the videos, because some live streams are like 2 hours, 3 hours long. So the reason why I say it's the bottomless pit is just because that's what science, if you listen to NASA, that's what they say. It is, okay, to get to space, what does it require? You can't do it in a balloon. You can't do it in a jet. Apparently you can do it with a shuttle, but it's not very effective, I guess. But whatever the case is, according to all the space agencies and everyone involved, you have to be moving at orbital velocity. Should we look that up? I'm not going to take away from the screen because I want to watch more of this video. But I'm going to read it to you when I look it up here. We're going to look up maybe a couple things. Orbital velocity. Because we're just going to go to Wikipedia probably. Yeah, that's usually a good place to go to get general information. So this is like their understanding of it is that it's a globe, and that's important as far as orbital velocity goes. So they think, I wonder if this is a, I was thinking maybe they had an animation. You know what? Let me do that. Let's go to images and just see what, maybe if I do, this might work actually. Okay, let's see if, which one looks like a good, we'll look at nasa.gov here, just see what this little thing looks like. Flight to orbit. Must be something else. Basically, it's like it's because we were born thinking of it this way. Here, maybe this one will work. Escape velocity. Okay, escape velocity. I'm trying to explain it with words and I'm not very good at it. I think if you go horizontally over like the side of a ball, tell me if that would be the same as just going into the heavenly realm where there is no physics to act on anything corruptible. So the whole world, me included, have been looking at this for our whole lives as outer space, and we're a ball in outer space. But that's not the case, guys. Let's see. I know you guys can't see it. There's no good things I'm trying to search. So you need to get going very fast. So I got sidetracked there with these images. Hold on. Sorry. It's very fast. And if you get up out of the air, here's a little, let's see here, I'll see if I can, okay. they go up, and then they start going horizontal, parallel with the Earth's surface. They're like, see, it says 100 miles. There's something like that up there. And what I'm saying is, when you do that, they're going to catch up to you guys. Look at the sky. Let me get a video of the sky lined up. I just want to show you guys that this is important. You got to understand that the real sky above us is like this amazing thing. Whoops. I have to grab a video really quick. Just a short clip of star trails. I probably have it a few places, but I know for sure I have it right here. Okay, let me put this up. Okay, I'm actually even gonna do this. I'm gonna make it so we can see it better by messing with the brightness a little bit. Oh, I had black and white on. You gotta see the colors. Turn the saturation up. Isn't that awesome? So I'm just messing with it, trying to get it to look really cool. So that's right outside my garage service door or whatever, the north end of my yard. I look up that middle star there, that's Polaris. So what they're doing is they're flying up there like this, but then when they get up out of the air or out of the atmosphere, they're starting to go in that clockwise or counterclockwise direction, whatever way that is. Basically they're trying to catch up to those stars. And if you notice the stars, I think this time lapse is 150 minutes, I think. Or maybe, is it 250 minutes? I don't remember. It's one of the settings on the P1000. But so they're trying to catch up with these stars. And apparently when they do, then they just stay up there. And what they think is that they're falling around a globe. So let's see here. Let's see if we can go back to that video at the same place. Maybe not. I'll find it though. Oh, I forgot. I never finished talking about why is it a bottomless pit. Because anything that's in orbit, they say it's zero gravity up there. They think they're free falling. Anything in space is falling. It's continuously, perpetually falling. That's why on Space Station, do you guys want to hear Don Pettit talk about this or do an experiment on the space station? I think I have a video. Don Pettit. What a crazy guy. My computer's really slow right now. Wrong folder. There it is. Ooh. I don't know if I played this one for a while. Don Pettit? Or is it Pettit? I'm just clicking it. Hope I don't regret this.
I'm Don Pettit, NASA astronaut. I'm an angry pig, and I stole the International Space Station. Space Station is a serious place. We're doing pig research. we have a regenerative life support system, which is a fancy way of saying serious research, scientific research, that we've got a research toilet that you use, and then a machine that goes chugga 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 chug, and then you go to the galley and you make yourself a cup of coffee. Serious research, scientific research, and that's exactly what you are thinking it is.
But water is such a precious resource up here that we also are cleaning up our urine and making it drinkable, and it's really not as bad as it sounds.
Better you than me.
We even recycle our urine.
Pig.
But before you cringe at the thought of drinking your leftover wash water and your leftover urine,
Chugga 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 chug.
This is the kind of engineering research that we're doing on Space Station. I want to do some physics demonstrations. Chugga 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 chug. Some eggs. And don't ask me how I got the eggs on Space Station. I've got a bungee spread across the...
Oh, that might be it for the program. Yep, Don Pettit was done, I guess. Oh yeah, Don Pettit was done. Starting up Don Pettit again, but it won't be Don Pettit. I'll have to change all the settings, I'm sure. So, yeah. Anyway, the Elon Musk thing, that's creepy. I know you guys know that I put videos out about that kind of stuff. Oh, there's the ceiling. It's still starting up. So you can see my flight to orbit thing there. I was just looking at that garbage. Let's see this though. This is something that's important, especially for people who think that we've known for thousands of years that Earth is a globe. Because sometimes we're wrong. So let's keep that in mind and read. This is Enoch chapter 80, verses 6, 7, and 8. And many chiefs of the stars shall transgress their order prescribed, and these shall alter their orbits and tasks, and not appear at the seasons prescribed to them. And the whole order of the stars shall be concealed from the sinners. I'm going to read that one again. And the whole order of the stars shall be concealed from the sinners, and the thoughts of those on the earth shall err concerning them, and they shall be altered from all their ways. Yea, they shall err and take them to be gods. And evils shall be multiplied upon them, and punishment shall come upon them, so as to destroy all. Somebody's going to be deceived about what the order of the stars is. Keep that in mind. Well, since we're talking about that, you know how a lot of people have been saying lately that the moon isn't a rock. Whoops, let's see here. But it's a light. Whoops. Look at this once. Look at verse 8. Enoch 41, verse 8. For the sun changes oft for a blessing or a curse, and the course of the path of the moon is light to the righteous and darkness to the sinners, in the name of the Lord, who made a separation between the light and the darkness, and divided the spirits of men, and strengthened the spirits of the righteous in the name of his righteousness. For no angel hinders, and no power is able to hinder, for he appoints a judge for them all, and he judges them all before him. Lots of secrets of heaven that Enoch saw. Lots of things. Too many to mention even. You know when, let's see, let's go there. Revelation 11. And there was given me a reed like unto a rod, and the angel stood, saying, Rise, and measure the temple of God, and the altar, and them that worship therein. But the court which is without the temple leave out, and measure it not, for it is given unto the Gentiles. And the holy city shall they tread under foot 42 months. So, check this out. In Enoch 61, I think it is. And then I gotta open another page. What is it? 6 or 7? Five? I don't know. Or is it 8? It's 8. It's 8. Sorry, guys. Ezekiel 8. And it came to pass in the 6th year, in the 6th month, in the 5th day of the month, that as I sat in mine house, and the elders of Judah sat before me, that the hand of the Lord God fell there upon me. Then I beheld, and lo, a likeness as the appearance of fire, from the appearance of his loins even downward, fire, and from his loins even upward, as the appearance of brightness, as the color of amber. And he put forth the form of an hand, and took me by the lock of mine head, and the Spirit lifted me up between the earth and the heaven, and brought me in the visions of God to Jerusalem, to the door of the inner gate, that looketh toward the north, where was the seat of the image of jealousy, which provoketh to jealousy. And behold, the glory of the God of Israel was there, according to the vision that I saw in the plain. Then he said unto me, Son of man, lift up thine eyes now the way toward the north. So I lifted up mine eyes the way toward the north, and behold, northward at the gate of the altar, this image of jealousy in the entry. He said furthermore unto me, Son of man, seest thou what they do, even the great abominations that the house of Israel committeth here, that I should go far off from my sanctuary? But turn thee yet again, and thou shalt see greater abominations. And he brought me to the door of the court, and when I looked out, behold, okay, that's not the part I was looking for, I don't think. That was weeping for Tammuz. Okay, it's verse 15. Then said he unto me, Hast thou seen this, O son of man? Turn thee yet again, and thou shalt see greater abominations than these. And he brought me, this is the part. And he brought me into the inner court of the Lord's house. Let's just remind ourselves here. Rise and measure the temple of God, and the altar, and them that worship therein. But the court which is without the temple leave out, and measure it not. For it is given unto the Gentiles, and the holy city shall they tread under foot 42 months. Keep that in mind when we're reading right here. And he brought me into the inner court of the Lord's house, and behold, at the door of the temple of the Lord, between the porch and the altar, were about 25 men, with their backs toward the temple of the Lord, and their faces toward the east, and they worshipped the sun toward the east. And he said unto me, Hast thou seen this, O son of man? Is it a light thing to the house of Judah that they commit the abominations which they commit here? For they have filled the land with violence, and have returned to provoke me to anger, and lo, they put the branch to their nose. Therefore will I also deal in fury, mine eye shall not spare, neither will I have pity. And though they cry in mine ears with a loud voice, yet I will not hear them. So then, check this out. Enoch chapter 61. And I saw in those days how long cords were given to those angels, and they took to themselves wings, and flew, and they went towards the north. And I asked the angels, saying unto him, Why have those angels taken these cords and gone off? And he said unto me, They have gone to measure. And the angel who went with me said unto me, These shall bring the measures of the righteous, and the ropes of the righteous to the righteous, that they may stay themselves on the name of the Lord of spirits forever and ever. The elect shall begin to dwell with the elect, and those are the measures which shall be given to faith. Because up here, they have gone to measure. And those are the measures which shall be given to faith, and which shall strengthen righteousness. And these measures shall reveal all the secrets of the depths of the earth. And those who have been destroyed by the desert, and those who have been devoured by the beasts, and those who have been devoured by the fish of the sea, that they may return and stay themselves on the day of the elect one. For none shall be destroyed before the Lord of spirits, and none can be destroyed. And all who dwell above in the heaven receive a command and power and one voice and one light like unto fire. And that one with their first words they blessed, and extolled and lauded with wisdom. And they were wise in utterance and in the spirit of life. And the Lord of spirits placed the elect one on the throne of glory, and he shall judge all the works of the holy heaven, or the holy above in the heaven, and in the balance shall their deeds be weighed. And when he shall lift up his countenance to judge their secret ways according to the word of the name of the Lord of spirits, and their path according to the way of the righteous judgment of the Lord of spirits, then shall they all with one voice speak and bless, and glorify and extol and sanctify the name of the Lord of spirits. I can keep going, but I think the temple of God. It's interesting. And yeah, Roderick was making some really good comments about where was it? I think I can scroll up and see it. Where did that go? Sorry, I'm scrolling up. Maybe I went too far. I know I commented right after. I don't know where it was. But yeah. This, like he was saying, oh yeah, that's what it was. He was saying about putting a pig in the temple of God. It's kind of weird. Neuralink. Alright, guys. I'm going to do a live stream about darkness. Literal darkness. Not that I understand what it is, but I understand that it's something that we need to be aware of. We need to be aware of what's happening there, and I think I can go through these books and the Bible, and there's so much information that changes my whole entire belief of basically how everything, like how cosmology is. The sky above us, there is a place. Here's what I say: space is fake, completely fake. But the darkness upon the face of the deep in Genesis 1 verse 2 is very real. And it's above the earth in the darkness. Yeah, go for it, Flat Earth Space Agency. Sure. Sounds about right, Flat Earth Coffee House. Says, look up when the last trumpet is. I think that's the cracking of the dome. So yeah, let's see. I think since that video, yeah, since it's not even in there anymore. So I think I'm gonna kick it, and yeah, thanks for hanging out for this quite strange live stream. And yeah, thanks, Flat Earth Space Agency. We will chat with you guys soon.